Alright, it's finally finished. I wanted to get this video in before the end of the decade. So now we can go back and look at the modifications for that JessEm lift. I did a video about, why I chose this JessEm lift, and here I am. I'm starting a mod to add the motor to it, which definitely voids a warranty on it. And I removed that screw, which only really took a couple of seconds, and took it out, threw it in my South Bend lathe, and I wanted to put a hole in the end of it there for my shaft. And my worst fear was that it would be hardened and I'd have to drill it with carbide and stuff, but it turned out it actually was very soft steel, so I was able to just go in there and start out with a center drill here. You can see, and that way you know that you're definitely on the center of the piece there. And I clamped it in a 3-jaw chuck. I put a layer of tape around it just to kind of keep from damaging the threads when I crank down on it. So here I am. I got it center drilled, and then I just went back and I used a little piece of 1/4-inch shaft in there. So I went back and I drilled an undersized hole. I'm a couple thousandths under with this drill bit here. And there you can see it's really basically nice and soft and drills easy, so that was a really good thing that made this modification go quickly. And in the end, by choosing this lift and not building the whole thing, it saved me many hours. It only took me like 2 hours to get this lift up and running. And then once I got the hole in there, I took a .2495 reamer. That's just a nice slip fit for the shaft I'm going to use, and just went through with the reamer there and made sure that I had a perfect round bore that was in line with everything. So that's it. That just took a second to do, and came out real nice, and everything's nice, centered, and ready to go. Couple of chips on the bearings there, but I tried to keep everything clean and protected. Then I'm over to the milling machine. I just wanted to throw a set screw across here so I could put a flat on my shaft that's going in there and just retain it with a set screw. It seemed to be the easiest thing to do, for this mod. So I just set it up in the Bridgeport and got the center drill there, so I'm kind of like breaking a thread right down in the V, the thread there, so hopefully I won't have any problems with threads grabbing or anything later. So first thing I did is I started with the center drill, and just you get the center of it all set up so that a drill bit will follow that little point that you put in there, and give you a exact centered hole in there. So now I'm just going to switch over to the tap drill bit there. It's a number 832 that I decided to put in here. And same thing, it's no problem drilling this shaft. It's nice, easy to machine metal, so that was a good thing. So that only took a couple of seconds there to put that hole in, and I just went half of the way through there because I'm just putting a set screw in from one side. And then it's back to tap the hole, and this is where you really want to be kind of careful and go nice and slow, and tap a little and back out a little, because the last thing you want to do is break a little tap like this in the hole, because it can be a beast to get out, and it can cause you problems. I just took it nice and easy with a little 832 tap and was able to get that threaded in there perfect. And then after that, I just took a little miniature file and went back and cleaned up the threads so there were no burrs or anything on them, so the nut would not have any problems in that area. So there it is. I got it all ready for the set screw there. And there you can see I got a little set screw that goes right in there to lock on the shaft. So that only took a couple minutes to modify that part. And it's time to go put it back together, and it's really easy to put this together. There's just a little bracket that holds the screw there, and the bearings slip right in there, nice tight slip fit. And then there's a little spring washer that preloads that you put on, and then you just have to put it up to the base plate there. And there are 2/4 20 socket head cap screws that come down from the top to lock it all in place. So it's really easy to take apart and put back together. And then I had pulled this one shoulder screw out. I'm putting back in because you really didn't have to pull that out, but I didn't know that at the time. Then it's just a matter of going back and getting the right wrench and just tightening everything up there. And we're just about back up and running. And then there's the nut for the screw is actually a 2-piece nut. The bottom half screws on to the threaded rod there first, and that actually, there's some little teeth in that platform that hold the router that lock that in place. And then there's a rubber O-ring that goes in a little groove in between that and the next nut. And then the second nut goes on there, which is just another brass nut there. And you can see that's got a little groove in the top there for the to mate with that O-ring that's on the other one already. And that's how they remove the backlash. You can see right there that groove, how they remove the backlash from this lead screw assembly on this. You just actually tighten the two nuts up with the and preload the rubber O-ring in between them there, and that takes all the backlash out and actually puts a little tiny bit of friction in the nut, so you have zero backlash. And then it pushes up into the platform there, and there's a couple of teeth that lock in there, and then there's a little dowel pin at the second nut. You can see that little groove in it locks on, and that keeps everything from loosening up. So once you get it all aligned, it actually slips in place fairly easy. Just a matter of getting the dowel pin aligned now. So there we are. Got, make sure there's no play in it when you put it back together. And if things wear in the future, that's how you remove the play too. You just tighten those two nuts up against each other and compress the rubber a little more. And then that little cap goes on there to hold everything in place. Now the threads that they cut on this shaft are not really an Acme thread or anything. They just seem to be a standard screw thread. So I wouldn't recommend running anything like this very fast. My motor is just going to turn it about as fast as you can hand crank it. So I got it all back together, and then I just played with it for a second to make sure that everything felt right. There was no binding or anything, and it all turned out good. Then I had a couple of stainless steel standoffs that I had picked up at a surplus place probably 30 years ago laying around, and they turned out to be just the right size and thread to fit on the end of those shafts. So it's a 2-inch spacer with a 1/4 20 thread on it. And I'm just going to take the screws that are on the end holding those stop plates on and just use them to mount this. And this is actually just a piece of it's a very stiff aluminum plate that I've had for a while laying around, and I just drilled the 2 holes there to mount. Now I'm gonna just go back and use a Sharpie just to mark out exactly what I want it to look like. And I'm just making this by hand. I really didn't want to waste the time out in the shop. It takes too long to set up and everything. So there you can see I just drew the shape that I wanted on it, the lines and stuff. And it's it's really easy to cut aluminum plate. I could have cut it on the table saw, but I just decided to use a jigsaw here. A little bit easier and a little bit, cleaner. So I got it roughed into shape, and then I'm just taking it back on the disc sander here, and just bringing everything right back to my lines there, and do the radiuses and stuff on the corners there. So it's nothing really fancy. It's just going to hold the stepping motor. And I figured I'd just show you that stuff like this doesn't have to be done on the machine. You can actually do it by hand. And then I'm just going to go back and clean up the inside where I took the jigsaw to it, and use that sanding drum there. And then a couple hole saws. This was a 1.5 inch pilot hole for the stepper motor, and luckily this hole saw was just a perfect size for it, so there's no play or anything. So you can see this aluminum machine's really easy, and that didn't take that long to do. And then I just center punched out the holes for the clearance holes for the screws on the stepping motor. And I'm just taking a hand drill here and going back and drilling the clearance holes for the M5 screws I'm going to be using. And there it is, just kind of set in place to make sure everything looks like it's going to line up. Now I wound up using 2 of those flexible couplings you can see there, because I didn't have one that had a 1/4 inch on each end to just run 1/4 inch shaft up. So what I did is I decided to use 2 1/4 inch ones and then a short piece of 8mm shaft. And there's my bracket with a little bit of spray paint on it. Now it's time to put it together. And you can see I put those rubber O-rings on for the stops, and then I got some real big fender washers there that are nice and thin to put on there to be a safety stop, which I really don't need with my end limit switches anyway. But so there's my extra 2 inches I've got there, just so I could clear the this biggest motor that I'm going to be using in there. This is that Milwaukee router, 3.5 horsepower. And then you can see the stepping motor. I just mounted that on there with some cap screws and bolts and nuts, and then I'm just going to go back and take the original screws with those washers that were on the end of the shaft there, and just use them to mount this stepping motor plate. That really just it just turned into a couple minutes making that plate there, and looks like it's going to work really good with this lift. And then I just tighten everything together. It's all got to come apart again anyway, but I'm just trying to set it up. And there I put the 2 couplings on. Like I said, I had a bunch of these couplings laying around that were 1/4 inch on one side and 8mm on the other, so I figured what the heck, I just put a 1/4 inch dowel down in the end of the screw there, and I ground some flats on it for the set screws, and then I just put another one on the top, and I'm just going to put a piece of 8mm shafting in between them to drive it. And now it's time to mount the DRO scale on the side there, so I'm just kind of working out where that's going to go. And I wound up making a little square aluminum block there to go on there and hold the top of it from flopping in the wind. Then I was able to cut it down to size once I figured out how long it had to be. And then I started mocking up a sawdust shield there for the bottom of it around the motor, and I used some PVC that was splitting pretty easy, and I decided to just use that for a template. And then I'm going to go back and I'm using this piece of Lexan here for that. And then I needed a little bracket to drive the DRO scale there, so I just made a little piece of aluminum bracket. And here it is. First move, it's just double checking that everything's going to work, and everything goes up and down fine. No problems. Everything's still tight, and just works perfect basically. So it really was a super quick and easy mod for what I did here, and I'll see how it stands up over time. I'm not sure if the nuts will have to be replaced or what, but only time will tell. And as long as I drive it slow, I don't see any difference between this and driving it by hand. So there you can see I had that PVC plate I started making up, and I actually transferred it to a piece of 1/4 inch Lexan there, just to have a durable piece that'll block the sawdust from going down below, and actually determine a gap so that the vacuum can pull up from below, and the router motor is not mounted in a vacuum chamber like with those other boxes people use nowadays. So it's easy to to modify this, in the drill press, just using some hole saws. And I figured I'd try to show you that you don't always need machine tools to do stuff like this. And then I, ready to set it in place. And I'm just using the 2 screws that hold that block in place to hold it there, because there's really, nothing other than a little bit of vacuum pulling on this. So that just slips right around, and it's got a clearance hole in the middle for the router that you can see there. So that just goes in place here, and in the end I was surprised this really did work good. I'll show you a little better how I blocked off around the edges and stuff. But it allows the router motor to get full airflow without any vacuum pulling back on it, which I think will make it last a lot longer. I think those boxes that you buy nowadays shorten the life. And then this is the little bracket for driving the that DRO scale. All it is a piece of angle iron I drilled the hole in. I'm just using a little automotive type stainless steel hose clamp to clamp it on that one shaft on the lift. And then I put a little piece of flexible thin plastic between it, just so that you have a little flex so you're not really putting excessive pressure on that DRO scale if something's out of line. So I just got that on there, and then just tighten the clamp and, holds it in place. Now the set of 10 inserts finally came for the JessEm lift there, and some people had told me they had a problem with them not sitting flat, and they had to sand them on there as well. I checked all mine, and I had 2 of them that actually sat just a hair high. And it turned out when I looked at the bottom, there was just a little mold, like a parting line, in a couple of spots. And I just took a real sharp chisel, and I was able to just scrape that off and knock it down. And, then once I put them in there, everything was fine on all 10 of them. They all sat perfectly flat. So, I don't know if you've got a problem with yours. I think you really ought to just contact JessEm to find out why, because mine, you can see there, every one of them. Let's see, what have I got? 13 of them now, and they're all, perfect. I just thought I'd show you that. And now it's, I decided I was just gonna, try to put a bit in and just try to take a couple cuts and just see how everything was, and, see if there's any vibrations or anything moves or anything. So I just put a little 3/8 round nose bit in there, and then you can see how nice that that power lift is. I can just crank it down, and you got to crank it down a little bit to put the small tight inserts in there. So now I'm just gonna use that, and I'm just gonna use I'm gonna make a gauge in the future with a little light on it and some brass buttons to set up 0, 0 on everything. But for now I'm just using a piece of board until I get it flush. And I've got my DRO there where I once I got it flush, I just set that back to 0, and then I can go back and now I can raise and lower my bit and do what I want with it, now that I know where it is. And basically it's I got the 3 speeds, and it's a little bit it depends on how close you want to get to it, which speed you use. That third, when you have it on the number 3, it moves pretty fast. The number 2 is slower, and then the number 1 that gets it down so it only moves a couple 10,000ths of an inch with the press of the button. So you can see I can just move it like a 0.5 thousandth of an inch at a time with that. So everything does seem to work good. Everything's nice, tight, repeatable, and stuff like that. So I'm happy. And you can see here's the fence. I'm just trying to bring that in and 0 that up, just so I know where the center of the bit is there. And same thing, I'm going to make a little gauge someday in the future. But I'm just using a square on that center line on the JessEm lift there, and that turns out that's perfectly centered. So I'm just going to come up against the square and then go back and reset that DRO to 0. Yeah, all I can say, it sure is nice not to have to fiddle around with clamps on the fence and moving it and trying to slide it a little bit and try to readjust it and stuff. It really did work out nice. I'm happy with it. And then, once I've got it zeroed, I can just take it and I can move it back to the exact number that I want. And, basically, that it's right there every time. So that's really, really does make it nice, and everything's nice and rigid, so nothing moves once it's, locked on that number. And it's going to take me a little fiddling around to, get used to the different speeds on there and stuff. And, but it does, they did work out good for my use. And now I'm just going to take a little piece of plywood and try that. And right there you can see I got a little hung up on that second piece of the fence. And turned out I had put a perfectly sharp edge on that. So I went back later and I pulled that off and just hit it on the belt sander with a little bit of a 45 on it that eliminated that. Because the two fences were perfectly in line, but just getting enough right there. Enough that it would hang up on it. And I don't have the dust collection on at this point. I was just, trying it prematurely. I'm waiting for the hose to come, and I just wanted to make sure that, when I indexed it, that the number came out, right when you went back and measured it and everything. And it's really dead on. So you can do whatever you want with indexing with this once you get it zeroed out. And then I got this nice Christmas present. I got this nice grinder for Christmas that I'm going to try out now. That JessEm plate, there's no way to put the screws in the corner. They don't line up with the holes in the saw stop top. So I took the grinder and I had it notch a little bit in the corners. And then I went back with a file just to, try to get a little bit of a radius in there to have clearance for the screws to go down through there. So this actually did take me a couple minutes to go through and grind the four corners, but it was worth taking the time, I think. And there you can see how everything actually goes down in the table now. And you got to wiggle it a little bit because that plate's actually wider than the opening, that plastic one. But it just fits in there perfectly. And it really does lock in there nice and tight. And, I'm really happy with this, that I did choose this lift to go with. And now you can see the 1/4 flathead screws they give you with that lift actually go down through there now. So then what I made is a couple of little 1/2-inch square little aluminum corner blocks that I'm going to put down underneath the table to just allow me to lock this down. Actually taking the cheating way out here, I'm just going to wipe that down with alcohol to make sure it's clean. And then I'm going to just use some Loctite super glue, gel glue on there to hold it in place. Now I don't know how long this super glue will hold or how well it will hold, but I figured I'm going to give it a try here now because I was kind of in a hurry. And if this stuff actually lets loose, I'll go back with some JB Weld epoxy and put these in place. But all I did is I put a nice glob of that super glue, and this is the thick gel stuff where it's going to go up under the casting. And then I just located that little bracket in the corner in position and dropped the screws down and just snugged them up a little bit to hold it for a couple hours until the super glue was nice and set up on it. And I did it on all four corners, and there you can see the little blocks are in place there, and it gives me something to screw into, and it seems like the super glue is holding, so that should be a good thing. You can see I did put some little foam spacers in there also to control the vacuum. And then I just took a little 1/16 inch thick piece of Lexan I took it out in the shop and bent it and put a couple holes in it there so I could use this just to block off the airflow from the back of that fence, because it actually sticks up higher than my my fence there. So that's adjustable, so when you slide them in and out, you'll have you'll be able to just move that. And then this this featherboard guard, actually when you raise it up all the way, it's got a spot where the air can actually suck in without getting chips and stuff. So I figured I'm just gonna throw a little piece of 1/16 of an inch thick Lexan, super glue that in place up there to, to give me a good seal. Then it was up to playing with the 3D printer. I've got that one access hole I had put in each side of the fence, but basically it had to be plugged because it lets vacuum. It's a leak for vacuum if you leave it open. So I 3D printed a bracket to actually hold the JessEm insert wrench. So this took actually something like this. It actually wound up taking 4 hours to print it, and you can see it. Just had the pocket. It had a lip to fit down in that hole in the fence there, and it had a clearance that's a perfect fit. I can't believe how perfect that came out. That printer is so, the numbers on it are just so on, and that actually just fits into that hole in the fence here, and I actually super glued that in place also. Now, one thing I don't like about these JessEm inserts is that the tight ones are a pain to pick out because you can't get your finger in there to pick it out. So I was just playing around with it, and I decided to throw some magnets on the bottom of the plate to see if maybe I could make it so I can pick them out. And I've got some little magnets I'm going to glue on the bottom there just to try for a while. These are just some test ones I'm messing with. I'm not sure if they'll collect too much sawdust and block the thing from going in there or what, but I'm going to play with that. I'll make a video about that when I get to it. And there you can see that fits right in there. And I was going to sell this old table on Craigslist, but it turned out I figured I'd only get like $50 for it, so I took a measurement and it actually fit on the end of my saw table exactly. I couldn't believe it. It just bolted right on there, and I made some legs for it from some old shelving brackets. And I decided I might as well keep it and, just use it for a spare when I want to do 2 setups. And then I bought 20 feet of hose because I got to run this to another dust port because the ones that I had were in the ceiling in another location up there. And then it's time to add the light. Now I had the bunch of these off-road lights, 18 watt, off-road lights I had bought years ago. And I decided I was going to use one of them because I really like the brightness of the light and everything. And just needed something to mount it with. And I found this $9 microphone stand rated for 1 kilogram on Amazon. I decided, what the heck, I'm going to play with that. It looks like it'll work. So I started by taking a bracket that mounts it and took that grinder, and again I didn't want to go down the shop, so I just ground the end off the bracket that had like the C-clamp on it. And went back and just ground it to shape a little bit and wound up with a nice bracket that I could use to mount it on my fence. So then I just had to go through and drill a couple mounting holes in it before I took a little bit of spray paint and touched it up. So I drilled one in the back there and 2 down from the top for flathead screws actually. Those 2 from the top were countersunk and I put flatheads in them to clear everything. And then I just located it on the table and did some center punches for the mounting holes and actually just drilled into the fence there, and I tapped the 3 holes to mount it. So I figured that way it would, be pretty much, move with the fence and always be in focus and stuff. And this is where it pays to have a wrench that ratchets when you're tapping. So there it is. I got the bracket mounted on there and, sprayed up the parts that I ground. And actually it worked out perfectly. I just had to make a nut up on the top there to mount the light on it. And I was able to use the existing mounting bracket and everything. And then I had a second output I wasn't using on my 36 volt power supply. So I ran the cables up. And I actually had a little plug in there just in case I want to unplug the light and get it out of the way for some reason. I don't know why, but I figured that it'd be easy to come on and off, and light worked out really good, and I was surprised because these are rated to be from 12 volts to 36 volts, and I never tried them on anything other than 12 volts. So they do work with 36, and here it is. When I turn the machine on, it comes right on. So now I'm just gonna try to route a couple edges with it. I've got the dust hose hooked up and everything, and I just want to see how everything's gonna work out. So I put like a half-inch round over bit on, or 3/8 round over bit on it, I think it was, and I'm just trying to set that up with the front of the bearing there and the bit. So there, we got the height set up, and then I'm just gonna lock the feather boards in place there. Everything really does work good, and it looks like it's going to hold it down good and give me plenty of options for longer boards with those wings on there and stuff. Then I start up the dust collector and start up the router, and the dust collector is actually twice as loud as the router is now. So I figured I'd just do a couple of round overs on a couple of these boards here. And that router is pretty amazing how powerful it is. It doesn't even slow down or make any noise or anything on stuff like this. And you can actually see that the dust collection is working. There's zero dust, basically. And there you can see that router is really quiet under this table, but there it is. There's zero dust. There's no dust on the floor. Those shields seem to have all worked in that secondary vacuum. I do have a little bit of dust that came out under the fence because I never put the piece of felt under there. I was gonna, but I'll go back and do that now that I know it works. It's the only spot that leaks. So you can see it's really easy to, depending on how fast I want to go and how much I want to move, to get a pretty precise move on the fence or even the router up and down. And actually, I don't really need any more automation than this, the way I see it. But someday I want to make a second version of this that actually that fence comes off and the CNC gantry goes in place of it, and it'll run on a Arduino. But for now, this is really my idea of a perfect setup for me. And here's a little look underneath. You can see I still have access to all the switches and speed controls. You can see I put another plastic shield in the front there to control the vacuum, and 2 little pieces of white foam to get that. You can see how that plate that slides up and down just has a 1/4-inch clearance all the way around it now. That's just perfect for the vacuum pulling around that pocket in the table. And so I figured I'm just going to go back and do a couple more cuts. Just raise the cutter up a 1/16 of an inch from where it was there. And I'm really just more piddling around now. But there it is, and thing just cuts so nice, so smooth, and you can see there's the sawdust collection seems to be working really perfect on it because there is no sawdust coming out with all these cuts. So there, I put a 1/16 lip on that, and then let's say you want to go up to an 1/8 inch. I'm just gonna take and hit the button, and I went up to I think with 100 thousandths. I can't really see from here. I forget what it was. But, it's easy to move it while the router is running and everything else, and it just sort of, stays right in position. And just a couple more passes. And, this basically, it's done now. Everything works. I still have to mount the little end limit switches on the router lift, but that just have to 3D print a couple more parts. And there you can see I can easily, set my dimensions and change them, and I'm really happy not having to use clamps anymore to hold things in place. And I still have to play with that balance on that little gate valve there. I haven't played with that. I just left it where it was set. But you can see the only thing I have is a couple of little chips coming out under the fence, which my felt pad will actually fix that quickly. So now I can finally get on to, starting to use it, and this is it. This is, exactly what it looks like, and you saw how it works, and I'm real happy the way everything came out. I have, plenty of storage for everything that goes with the router. I've got all my bits organized the way I want them to be organized and stuff on those little trays that I can just, pull out and set up on the bench and work with. So I got them, and then I've got the room down below there for, where I'm going to put some of the spare bits too. And I do have a squeaky hinge on that door I have to fix. And then I've got the drawers with all the wrenches, and that one's got some junk in it now. I've got to clean that out. But basically everything's organized now. And I got a spot to put the routers as I switch out the big one. And all the the vacuum lines work, and they're all buried in place, and I don't see any problems with any of that now. The lift worked out real good. These little wings do give it a lot of support on longer boards, I find out. The little screws, I don't think I'll ever get any sawdust down on them the way it looks. And all the wiring's pretty much plugged in, so things will be easy to fix later if things go wrong. And then you can see the on the back side, the electronics are all enclosed, and then I have these extra drawers that are really nice to keep all my routing stuff together. Everything's in one little cabinet I can roll around now, and all the extra routers fit, and jigs and everything else. So this is basically it. This is I did spend a couple months building it, and actually I went over budget. I'm up a little bit over $1,800 now, but that's including the router, the lift, the tabletop, all the router bits I bought, all the inserts, and all the feather boards, and everything. So I don't feel that's really too bad. I was shooting for $1,500, but I didn't include all the other accessories either. So this is it, and I just thought I'd do a final finish up on this to let you know it's finally done and on to some other projects. Thanks for watching. Please subscribe.